Hello, welcome, and thanks for listening to Carbon Cli-MATES, an energy podcast dedicated to discussing all things energy, carbon, and sustainability while pointing out what's getting hot aside from our planet. I'm your host, Enya, and today I'm joined with my Carbon Cli-MATE co-host and boss, Alan, who I'll be introducing shortly. Alan, how has your week been, and can you tell us a bit about yourself?
Thank you for having me on the show, Anya. And it's been quite busy, so I'm getting ready to go on a holiday for the week. So
lovely.
I've been tortured all week with people trying to get the things done. So about me then, so I'm the director of BPP. I've been involved in building services for about close to 40 years.
Wow.
And I've been in the Colville Group for about 27 years. In the past 6 of that, I've been the director of BPP, which is a sustainability company with energy and sustainability. And that's kind of a bit about me.
Nice. And so, yeah, you said that. And see, when you were at school, I know maybe around like GCSE time or maybe like around the 14, 15-year-olds, your 14 or 15-year-old self, did you ever like envisage yourself in the sector where you are now?
Sector, because the sector I first went into was building services, and building services can be a hidden sector. I didn't think it would be an engineer, because you always liked engineering, you always liked mathematics, so like discovering things, and I sort of naturally gravitated towards that sort of job. And when I first got into building services, I didn't really know what it was because it was all pipes and lights and hidden things.
Yeah.
And it led a whole new world of discovery of things that are hidden behind the way it works. And that led on to the interest in energy and so I wanted to know that it could actually make a difference in the world. You sort of, there's a whole hidden world, and it sort of became fascinated with it. So.
Okay, brilliant. Okay, well, as you just said, so BPP, we at BPP are sustainability engineers, and our primary role is to act as energy assessors for buildings during construction, and usually they can just be existing as well. So we do this by usually talking to the client and understand what they want to have designed for the building. So it goes down to the heating, hot water, and ventilation, types of walls, windows, etc. The list goes on. Once we have this information, we then input it into a specialist software, and this gives a carbon score or building emission rate against the calculated target score or target emission rate, essentially how much carbon the building is being emitted. For domestic softwares, this is shown through SAP calculations, and for non-domestic softwares, this is shown through Bruegels. And these softwares also produce an EPC rating, which is an energy performance rating. I go into more detail about this in episode 1 of the podcast, but I just wanted to like recap and summarize this as we'll focus or like tiptoe around these subjects today. So the scores I've previously mentioned, the BER, the built-in emission rate, and TER, they are able to fluctuate depending on what type of technology, equipment, and constructions the buildings are designed to. So this could be the type of boiler, amount of insulation in the window, or whether the amount of insulation in the wall, or whether the window is double glazed or triple glazed, or if there are any renewable technologies installed. So, Alan, the energy sector is constantly evolving with these different renewable technologies, energy efficiency methods, etc. But what have been the major changes you have witnessed with regards to what we just talked about?
It's an interesting question, and it's probably important to understand that when you're looking at a Bruegel or a Part F or a building regulation calculation or an EPC or a real life calculation, they're all different and they mean different things. And what you're seeing is the emergence of people being more aware of what they actually mean. Put in some perspective, a building control calculation is a comparison with a theoretical benchmark that's used as to sort of it was the first sort of experiment with the regulations to sort of come up with some way of creating, is my building good enough? Is it not good enough? An EPC is a theoretical comparison with a standard reference building. So it's how you compare to a certain building. You're not being compared against the benchmark building.
Yeah.
And a real life is what people really are starting to get into for it. So what you're seeing is that you're seeing a progression of how people think of energy and tackle energy. So you have, when building regulations first sort of came in around sort of mid 2000s, you would have had, things like boilers all of a sudden couldn't be sold because they weren't efficient enough.
Yeah.
And people started thinking about that because they were maybe before that they were thinking about, well, this is a very sturdy boiler, it's very robust, it'll last 50 or 60 years. But it's not very efficient. And then people started thinking about that, and you found people selling boilers getting quite upset that they couldn't sell the boilers anymore. And as the progressions move forward, so heating, boilers, ventilation started getting looked at in a lot more detail. You had lighting starting to become a bit more detail, and the progression is going further and further into the fabric of a building. So you'd have the U values, the windows, the glazing, the orientation of it. That has more focus because it's almost like the services have been squeezed as much as they can. That's where we're going. So you see that progression coming into it. You also see more importance put on to some of the badges you get, like how much you improve over a Bruegel calculation or how much you have an EPCA. And that's coming from different sources. So firstly, it came from the regulations themselves, forced people to make a change. You then have planning influences where some planning councils will say, in order to build in this area, you have to have a certain value. We're now seeing it progressing more with financial institutions saying that we will not invest in a building or invest in a development without you having certain sustainable goals. And a lot of that's from public pressure and public awareness. So it's becoming higher in the public awareness, which is feeding through in a very odd way. So we're seeing it's more awareness, I think, on it. So
That's that's brilliant to see. And even what you're saying there about more awareness, I'm even finding when we're talking to different people in the design team, the likes of when we're talking to the architects, we're discussing U values, which is measure of heat loss through the wall. And I remember at the start, it used to be this U value. Yes, we're going to give you this figure. But then we actually started like, okay, actually, how's that achieved? Like, how much amount insulation is that in? Like, is that in the wall? Or what, we didn't take account for like bridging, the steel, the timber frame construction. And I feel like this is starting to be looked at more because U values are getting tighter and just people understand what exactly that means.
yes, I would agree with that. And again, it's because because of the progress of sustainability through the services and the fabric, that because the services are being reduced so much, there's less heat loss in a building. And then you're finding that things like the thermal bridges and the way that the wall is constructed, that in the past may have had a small change on the U value, now becomes quite a dominant change on the U value. So to squeeze that last bit out of heat retention, you have to look at those areas, and that's becoming more and more of a focus for the design team to look at. So
Yeah, it's really great to see. It's really great to see. Well, you definitely just from your previous explanations there, you've like a vast majority, like vast, like have knowledge. Or like, how did you do any particular training to get that? Like all the energy accreditations you have under your belt, or is there a particular route you would recommend for people to go down to get to the point where you're at today?
that's a good question because energy assessment sustainability is relatively new. It has always been about, but it's relatively new compared to other professions like the sort of mechanical engineering, electrical engineering, and architectural can go back sort of centuries. Um, so I would say be curious.
Okay.
So the thing that kind of drives me and has driven me is to do with the curiosity of how things actually perform in real life. So the one thing you always have to be aware of is whatever you're assessing, whatever you're doing, what is the real life scenario and what is happening in real life? And that's kind of what drives a lot of the experience and practical knowledge. So a lot of that is actually common sense. So you develop an awareness of common sense. Now, that's not qualifications or anything else. That's just being aware of how things react in real life.
Yeah.
What's the consequence of doing something or not the consequence of doing something. So you need that as your core starting point, and you build off that. Then there's formal qualifications. You can have, there are good mathematics, you can come from a geography background, a mathematics, or an engineering background. It doesn't really matter as long as you've got that core kind of sense of curiosity about the world around you, and perhaps a concern about sustainability of what you're doing. So the formality of it, there's a couple of routes. There's sort of sustainable assessment, which forms into it, as well as things like the BREEAM assessors, which is formal routes through the BRE. There are then formal routes to energy assessment accreditation. So you need that to do an EPC. And in order to achieve that, that would be, so like so the CIBSE or Elmhurst or somebody like that can offer that accreditation. But in order to have that, you would probably have to have a degree and a master's degree off the back of that. So that's kind of where that's coming from. So that's where the educational route to get to that point. And from then, you then build off various sort of courses or specialities of that. So you can get into the fabric and look at the U values and look at those sorts of things. And it's worthwhile having training separately from those. You would look at the energy assessment. You would look at real life predictions. You can do courses and those, and they're all sort of tap into it. So the sustainability isn't so much you do a qualification to become sustainable. You do a qualification to get into sustainability, and then you continue for the rest of your career doing courses and revising and looking at CPDs and continually learning as the process evolves to keep on to sort of keep on top of everything. So so it's a sort of a strange thing. I think but the biggest thing, if you're curious about the subject, you can come from any background and get into this from any way. You don't have to start at age 12 and become a physics master to do this. This is the sort of thing that you learn and you can adapt.
That's really great to hear, because one of the main reasons I started this podcast, I started for many reasons, but this main one, I know so many people who have trained up, did a degree at uni in some sort of something, go into the real job and they realize they hate it, and then they feel like they're stuck, and then they spend their life maybe the next 5 years unhappy, searching for different routes. But showing them that you can have any degree you want and you can come into this really interesting ever changing industry that's going to be at the forefront of so many news articles, to show them it makes it exciting. If you advertise that to anyone, they'll be like, yeah, I want a bit of that exposure there. But yeah, don't know if that's really good to hear, Alan. Okay, so now we are coming to the question round. So this is the assessing the assets section. So this is just a wee section where I maybe talk about different technologies we've both come across as energy assessors. And then I'm gonna have a wee fun bit later on, which I'll explain the details just before. So there are many different technologies that can be installed in your house or building that can help reduce energy. So, Alan, I'm going to list some energy saving technologies or techniques or words that we come across when we look at a building. I'm going to list the opposite word.
Okay.
So you have to guess.
Sounds curious.
Okay. I've got two really hard ones, and then I've got some hopefully you should be able to get. And then if you do, I'll keep on doing this, and if not, we never mention this section again.
Okay, that's cool.
Okay, so the first word is cold gain.
Loss.
Yes, exactly. So yeah, we come across heat loss. Yeah. Okay. Next one, me worthless.
Sustainability.
Yeah, me worthless.
You value.
Yeah, exactly.
Very good.
Okay, this one and more. It's difficult because it is a sustainability term. Glare.
I think the opposite of glare.
Glare.
The same thing. Curious about what I do.
Shading.
Shading. Oh, okay.
Okay. Now this one, these two, they weren't my best, but I'll see what happens. Okay, and it's a specific type I'm talking about. Okay, solid opening conductor.
They are tricky, huh?
Mm-hmm. Okay.
I can't get that.
Solid opening conductor, cavity wall insulation. Okay.
You
And
got me on that.
I've got one more, and again, it might be a stretch, but
Okay.
like then people can play at home. Like they can see if they
Okay.
can get this. Conserve, fire, cold, loss.
What was that again? So,
Conserve, fire, hold, loss.
I got the first bit. That's something he'd give.
Oh, right, okay. Wastewater heat recovery.
Yes, something to do with something else. That's very good. You know what you should do? You should create a crossword.
Yeah, I really, yeah. It should,
Like a version of the Times crossword where you have to.
yeah. It'll be, yeah, I'll go out simultaneously with this.
Very good.
But yeah, okay, well, thank you for playing the assessing the assets round. I hope you enjoyed yourself.
That's been great. Yeah.
Yeah. Okay, well, Alan, as you mentioned, you're accredited to assess buildings in Northern Ireland, Wales, England, Scotland, and Republic of Ireland. So that's a lot of different regions for like to assess energy. I think we kind of did touch on this, but what is your favorite region to assess in?
Okay. It's kind of interesting. Like they all have their plus points and different strategies for doing things. I think probably as a favorite, it would probably be England. Might be an odd choice, but it's really because it's probably the more progressive, and you can assess it using software that allows you to get a good insight
Okay.
into it. So I think that's probably where the rest will go to. Aside from that, so that's probably why, because you can it's more advanced and you can assess it using software that allows you to get really into the calculations and see why things and what can influence it in a better way.
That's okay. That's great to hear. I know one of the big changes that happened for us in I think was it September 2020 or September 2018 was the release of the energy assessment guidance for the Greater London Authority. What that did is that mentioned a particular section where it talked about the carbon factor of electricity and the effect all the connecting to the renewables, all the connection of renewables to the national grid was having on electricity. And for us, it was I think we were assessing stuff. A lot of the developments maybe had gas boilers or like they're really primarily focused on gas. But then when this came out and it showed electricity had nearly like halved in the amount of carbon it produces per kilowatt hour, it really changed the game and like made electricity a front runner and like look at Arthur's heat pumps.
Yes, it did. It was almost like the best kept secret of
Yeah.
the national grid. It kind of been bubbling for a while, where electricity was, I suppose, seen as a poor thing or a bad thing, I guess, in some way in the past. But with the advancements on the UK grid and actually the grids throughout Europe as well, is that it has become quite sustainable, and there's this change for encouragement to move away from fossil fuels into electricity, where it goes to. So it's probably going to cause its own issues because we'll all want to connect to electric, and we can't all connect to electric. So there's going to be a point when how do you grow the grid and how do you maintain the grid, and can you maintain that factor in the future, because you're going to have the renewables. Can the renewables keep up to keep the value down as it expands? Maybe 2 or 3 times the capacity of what's needed there. But it really did change everything. So that, and it changed, I suppose, the technologies in vogue at the time would have been CHPs, and because the electricity that they were offsetting against the sort of poor performance of gas was encouraged, but it's not so encouraged now. So it's changed into more heat pump technology that's moved into. So it has really changed the landscape of the sustainable assessment.
Even from heat, like I know heat pumps that been the last big like phase, like craze the last couple of years in the energy industry. But I think even now that's moving on. I'm hearing a lot of talk about hydrogen and hydrogen boilers and all.
Yeah. There is each technology is great, and each technology has its downside. I have a kind of personal theory that it takes about 5 years for people to figure out what they don't like about a technology and then try and move into something else. So um, the hydrogen boilers is interesting because hydrogen boilers is very like a gas technology, and gas has the advantage of being able to switch on and off very quickly and react to things very, very quickly. So, and can operate at higher temperatures and whatnot. So, there's always been a trouble of where you get the hydrogen from, and that's always a concern. And the overall sustainability is slightly in question. But if that was ever solved, then it's a very adaptable technology because you can pack a lot of energy into something like hydrogen. There's also maybe a perception that some people might think hydrogen is dangerous. I suppose they've had natural gas in their houses for a while. I suppose hydrogen sounds like it's a dangerous thing, but it's just another gas. But yeah, no, it's an interesting thing. Heat pumps are a very good technology. They're quite clean. There's no emissions off it. They're easy to handle. They like to operate at low temperatures, which is probably where its downside comes from. It's harder to operate at higher temperatures if you need that service. But they're all good to handle. They all work well with the handles. But, yeah, it's interesting to see the change of how things move.
That's a really interesting point you made just there about perception of, because I remember when I was doing my thesis and I did it on a renewable electricity grid in Derry, and someone, and like this is maybe in like 2017, so not that long ago, or it doesn't feel that long ago, but it probably is. And I was like, put the title, and I did the thing where graduates do. They put the thesis title on Facebook, and I'll like show everyone this is what I was working on, get all the likes. And someone commented underneath it. I was like, oh sure, they mentioned the RHI, or they mentioned about renewables, and they had like, it was like, oh sure, that'll be a lot of good, and had like negative connotations with it. And I was like, that's amazing to see that, you know, even though the RHI scheme, which was years ago, people still view renewables, especially here in Northern Ireland, like that as a bad thing, like, and they perceive it as like,
yeah, it was a pity because it was actually quite a good scheme. It was just, I suppose, badly managed.
Yeah, exactly.
In some way, it was, but there is that perception that can happen. But there's also like an infrastructure that backs it up. You know, for 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 people to different the heat pumps, then we have to have a dwelling that's suitable, it's well insulated, and they also need to have an electrical capacity that can take it, and maybe some of the local grid areas can't take that. And
Yes.
so there's a bit of a perception, or some people don't like wind turbines on the landscape. Some people like wind turbines in the landscape, and you can sort of see the perception that will probably change, and renewables will just be a thing that exists. As it gets more common, it becomes something that people can accept. Or you identify issues with renewables that can have connotations. You know, you put some sort of tidal system into something, and it might affect the fish in the lake. So that sort of thing that can happen, but you can deal with it and you get over it. And it's the future of having this mix of renewables. So I think people are probably more accepting now. Especially as the cost in energy's increased, and because the cost has increased, there's more of an awareness in people's minds about it, and so saving energy is something that's forefront of people's mind, and therefore they accept renewables a bit more, I think.
That's great. When we talk about the cost of energy, I definitely want to focus on an episode where we break down the price of electricity, like just because that's the highest one, and just exactly. Well, I suppose I do the price of all fuels, but just exactly what goes into it. But yeah, that'll be for a future episode. But Alan, you've been great to have on. Like, thank you so much for answering all the questions. And just before we go, do you have any advice for future prospective energy assessors or engineers who are looking to get into this particular sector?
Okay, sort of going back to an earlier answer is that it's good to be curious. And so sometimes when you're starting out and maybe you're just getting your foot in the door of this and you're not quite sure how it's working, and you may get some advice from people. Take the advice, but also make your own advice up. Think about what you're doing and where you're going, and as you discover things, try and learn why that happens and what the real life consequences of certain things are. So if someone tells you how to do a calculation, try and figure out why that calculation works, because that will lead into something else. And those calculations then embed into your common sense, and you can start making reactions. So something that's kind of over me, and I was told when I was sort of training, is that sometimes you may only have 20 minutes to make a decision on a project that can change its whole direction. And you don't have time to work it all out, but you've got that 20 minutes, and can you make a difference in those 20 minutes? And if you can, you could have such an influence on our development.
Yeah.
And I think having that as your core, so listen to what advice people give you, but question it as well. And because you're in a fast evolving area of development, and you can be the one that actually makes that change. Don't think because other people have done something for 20 or 30 years that that's the way to do it. Mm-hmm. You can make it, you can do it differently, you can do other things. And so just have the confidence in yourself to make those changes and to see them. So I think anyone starting out should have that ability, you know. And if you're not sure of why someone's asking you to do something or why a calculation has to be done a certain way, find out for your own curiosity, because it just lets you see it a bit more. And that's how you develop. So.
That's really great to hear. That actually is kind of similar to the advice I was going to give, which is not as detailed and nicely phrased as your advice. It's like when assessing carbon in a project, always check why it has carbon happening. Yeah, again, like, you know, and like, you know, just like, yeah, what we said was the same thing. It's like, no, it wasn't. It was far less serious. But again, thanks for being on.
Okay, thank you.
And you'll definitely be back. Yeah.
Right.
Thanks for listening to Carbon Cli-MATES. If you follow us on Instagram at carbon_Cli-MATES, you will keep up to date with all our latest releases of episodes and news. Okay, thanks for listening. Bye.